Hello everyone, I welcome you all for the second session of the chapter Ray Optics. In our previous session, we had discussed about the refraction of light. What is refraction of light? And also we had drawn a diagram to show the refraction of light through a glass slab, correct? So let us understand it again. What is refraction of light? A refraction of light is the phenomenon of the change in the path of light when it is traveling from one medium to the another medium, correct? So we had drawn a diagram to show the refraction of light. So if you say this is a rectangular glass slab, you consider this as a rectangular glass slab. Let us say that a ray is incident obliquely, okay? A ray is incident obliquely at the interface of two media. Let us say that this is the first medium and this is the second medium. Next, at the point of incidence, we need to draw a normal. A normal is a line drawn perpendicular to the interface, and then the ray is going to refract it like this. So if the rectangular glass slab is not present, what is the direction of light? The direction of light should be like this. So it has to go like this. But because of the presence of this medium, the light is just bent towards this normal. And we said that this is the angle of incidence I and this one is the angle of refraction R. So what are angle of incidence and angle of refractions? The angle made by the incident ray with the normal is called angle of incidence. The angle made by the refracted ray with the normal is called as angle of refraction, correct? Now we have to write the laws of refraction. So in this class we are learning about the laws of refraction, the laws which are governing this phenomenon of refraction. Let us understand the first law first. The first law of refraction says, so let us write the heading as laws of refraction. Laws of refraction. Under that, the first law states that incident light, refracted light, and the normal at the point of incidence, all lie in the same plane. So the first law of refraction says that incident light, refracted light and the normal drawn at the point of incidence all lie on the same plane. So if you say this is an incident light, AB is an incident light, BC is a refracted light and this MN is a normal, okay? AB is an incident light, BC is a refracted light and this MN is a normal drawn at this point of incidence. These lines all lie in the same plane. So that is the first law of refraction. Next, let us write the second law. This is very important for you, and this law is also called Snell's law of refraction. Snell's law of refraction. It's a very important statement. Let's understand the Snell's law now. I said that this is the angle of incidence and this is the angle of refraction. This is the angle of refraction. Snell's law states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media, okay? So the statement of the second law of refraction, that is Snell's law of refraction, is this: ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. So we assumed that this is the medium 1 and this is the medium 2. The light is traveling from the first medium to the second medium and it is undergoing a refraction, and this is called angle of incidence. The angle made by the incident ray with the normal is called angle of incidence, and the angle made by the refracted ray with the normal is called as angle of refraction. So if you write the ratio of sine of angle of incidence, sine I, divided by this one, sine of angle of refraction, or the sine of angle of incidence to the sine of angle of refraction, this ratio is a constant. Okay, this ratio is a constant, and this constant is written as sine I by sine R is equal to, this constant is written as N21. Okay. So this constant is written as N21. So what is this N21 stands for? This N21 is nothing but, we will write it here, N21 is the refractive index of medium 2 with respect to medium 1. Okay. Let us understand the statement again. The statement of the Snell's law or second law of refraction is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. So this is the statement. Up to this, it's a statement. Then if you write that in a mathematical equation, you write this one, sine I by sine R is equal to constant. By drawing this diagram, you can write sine I by sine R is equal to constant, and this constant is written as N21. What is this N21 refers to? This N21 is a refractive index of medium 2 with respect to medium 1. So this is about the Snell's law of refraction. We said that the ratio of sine of angle of incidence to the sine of angle of refraction can be written as N21, which is called as a refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. So this refractive index depends on the two factors. So this refractive index is a constant for a given pair of media. Let us say that the refractive index of this glass, this is coming from air. The light is incident from air to glass. So for this pair, the refractive index is a specific, it is a constant. Or if we consider the light is entering from water, let us say that the light is entering from water to glass, then this refractive index will be different for that. So the refractive index depends on the pair of media. Okay, let us write that refractive index depends on the pair of media. Then secondly, refractive index depends on wavelength of light. See, the light, if it is a monochromatic light which will be having a single wavelength, if the light is a white light, composite light, the composite light consists of 7 different colors, and those 7 different colors are having a different wavelengths. Therefore, the refractive index of this medium also depends on the wavelength. So wavelength of this incident light. You can understand a refractive index is nothing but the ability of this medium to bend this ray. Okay, the ability of this medium to change the path of light. That is what we called as a refractive index. So the refractive index depends on these two factors. So it depends on the pair of media, from where to where the light is traveling. So it depends on the pair of media, correct? And the refractive index also depends on the wavelength of that incident light. And importantly, a refractive index is independent on angle of incidence. Okay. So if you go on changing this angle of incidence, refractive index will not vary. Okay. If you change this angle of incidence, accordingly the angle of refraction also changes. but the ratio of sin I to sin R remains constant. Okay, so by changing the angle of incidence, we cannot vary the refractive index. It is a characteristic property of the medium. So refractive index is independent on the angle of incidence. Okay, if the angle of incidence changes, accordingly the angle of refraction also changes by keeping the ratio of sin I to sin R constant. That is why refractive index is independent on the angle of incidence. Okay, we have two types of refractive indices. Okay, types of refractive index. Okay, the first one is a absolute refractive index. Absolute refractive index, which is simply written as N. So what is this absolute refractive index? Absolute refractive index is the refractive index of any medium with respect to air or vacuum. Okay, so refractive index of any medium with respect to air or vacuum. So this is called as absolute refractive index. We can write the equation for absolute refractive index as N is equal to C by V. Okay, N is equal to C by V. What is this C? C is the speed of light in air or vacuum. So the ratio of speed of light in air or vacuum to the speed of light in a given medium. Then we define a absolute refractive index. Means if you consider the light is entering from air to any other medium. Okay, the first medium has to be air only. While defining absolute refractive index, the first medium has to be air or vacuum. So if the light is entering from air to any other medium, okay, like water, it may be glass or anything. If the light is entering from air to any other medium, we define the refractive index of this medium with respect to air as absolute refractive index. The equation is N is equal to C by V. C is the speed of light in air, V is the speed of light in a medium. Then we also define the second one, which is a relative refractive index. Relative refractive index. Relative refractive index. What is this relative refractive index? Refractive index of one medium with respect to another medium. Okay. So refractive index of one medium with respect to another medium is called as relative refractive index. Means the two media, the medium 1 and 2 may be anything. Like it may be water and glass, it may be glass and water, it may be from any other liquid to glass. Likewise, if the medium 1 and medium 2, so they are of different medias, then the refractive index is defined as a relative refractive index. Okay, refractive index of one medium with respect to another medium. So this is what we called as a relative refractive index. How do you write the equation for this? N21, which is always written as N21 is equal to N21 is equal to V1 by V2. Suppose if the light is entering from water to glass, okay, first medium is water and second medium is glass. Light is entered from water to glass. So the velocity in water, the speed of light in water is V1 and the speed of light in glass is V2. Then the refractive index of the medium 2, that is glass, with respect to the medium 1, water, that is N21 is equal to V1 by V2. We also write the equation for this N21 as, this N21 can also be written as N21 is equal to N2 by N1. Okay, N21 is equal to N2 by N1. What are these N2 and N1? N21 is the refractive index of glass with respect to water. This N2 is nothing but refractive index of glass with respect to air or vacuum. So this N2 is a absolute refractive index. Okay. So we can write N21 as absolute refractive index of medium 2 divided by absolute refractive index of medium 1, or simply refractive index of medium 2 by refractive index of medium 1. So we have two types of refractive indices. First one is the absolute refractive index, which is the refractive index of a medium with respect to air or vacuum. The first medium should be air or vacuum. N is equal to C by V, the equation. Then for relative refractive index, so relative means we are comparing two mediums. So the mediums may be glass and water, or maybe water and glass, or any other liquid to glass, likewise. So if the light is entering from one medium to another medium, we define refractive index of this medium with respect to this medium, which is nothing but a relative refractive index. N21 is equal to V1 by V2, and N21 is also written as N2 by N1. So from the previous topic, we had written N21 as N2 by N1, correct? So Snell's law is written as, sin I by sin R is equal to N21. If the light is travelling from first medium to second medium, sin I by sin R is equal to N21. Here we can substitute this N21 as N2 by N1. Therefore, sin I by sin R is equal to this N2 by N1. This is N2 by N1. Hence, we can cross multiply these. Therefore, you will get N1 sin I is equal to N2 sin R. Okay. So this is another form of Snell's law. N1 sin I is equal to N2 sin R. So this is another form of Snell's law. Okay. How do we write this? We know that N21 is equal to N2 by N1. Snell's law says that sin I by sin R is equal to N21 when the light is entering from first medium to the second medium, where this N21 is the refractive index of the second medium with respect to first medium when the light is travelling from first medium to second medium. So sin I by sin R is equal to N21. We can write this N21 as N2 by N1 from this result. Therefore, if you cross multiply this, you will get N1 sin I is equal to N2 sin R. That is another form of a Snell's law. Okay. Now we will be writing a very important one, that is a limitation of Snell's law. Means where we cannot apply the Snell's law. Okay, let us write that. Limitation of Snell's law. Where does Snell's law is going to fail? Okay, so this may be your 1 mark question. Where does Snell's law cannot be applied, or where does Snell's law is going to fail? So that's the question. See here, when the light is incident obliquely, okay, when the light is incident obliquely at the interface of two media, it suffers the change in direction like this. Okay, it suffers a change in direction like this. But imagine when the light is entered along the normal. Okay, the light is entering along the normal. So normal is drawn at this point, and the light is also incident along the normal only. Then how does refracted ray goes? Refracted ray goes like this, which is also going perpendicular to the interface. Now in this case, what happens is, in this case I is non-zero, correct? I is not equal to 0 here. But in this case, what happens is I is equal to 0, that is angle made by incident ray with the normal. They are along the same direction, means the angle should be 0. And here angle of refraction is also equal to 0. Correct? So if angle of incidence is 0 and angle of refraction is also 0, means the Snell's law, if you write Snell's law as sin I by sin R, what you will get is sin I is 0 divided by sin R is also 0. So sin 0 is 0, sin 0 is 0, means we will get a 0 by 0 form. In this case, Snell's law is going to fail. So this is the limitation of Snell's law. Okay. So you may get a 1 mark question. Where does Snell's law is going to fail, or what is the limitation of Snell's law? For the normal incidence, the angle of incidence becomes I becomes 0, and also angle of refraction or becomes 0. Okay, for the normal incidence, the angle of incidence I becomes 0 and also the angle of refraction R is equal to 0. In this case, Snell's law is going to fail. For the normal incidence, Snell's law fails to explain the refractive index. Okay. Now we need to prove an equation N21 is equal to 1 by N12. Okay, we need to prove this. N21 is equal to 1 by N12. Here N21 is the refractive index of second medium with respect to first medium, and this N12 is the refractive index of first medium with respect to second medium. So how do we prove this? For this, let us consider a refraction through a rectangular block twice. Okay, here this is an incident light, AB is an incident light, BC is the refracted light, and again at this interface. This is glass and air. Imagine that this is air and this is glass. Now again light has to travel from glass to air at this interface. Okay. Now imagine that this is a incident light for this refraction. At this point, for this refraction, this is an incident light. Say that this is the angle of incidence at this point. I dash is the angle of incidence for this refraction. At this point, the ray will refracted like this. Okay, and say that this is the angle of emergence. We say this CD is the emergent ray. We should call this CD as a emergent ray, and this emergent ray is making an angle of E with the normal, and this angle is called as angle of emergence. Now let us apply Snell's law for this refraction first. Okay, applying Snell's law for this refraction for the first interface, okay, at this point. So sine I, sine of angle of incidence to the sine of angle of refraction, this divided by sine R. This can be called as refractive index of second medium with respect to first medium. So this will be N21. Okay, let us call this as equation 1. Call this as equation 1. Next, applying Snell's law at this point, at this interface. Now the light is traveling from glass to air, or the light is traveling from second medium to first medium. Okay, second medium to first medium. So the angle of incidence is I dash here. Therefore, let us write this sine I dash divided by, here this is angle of refraction. E is the angle of refraction. So this is sine E. This is equal to, here the refractive index of this medium where the refraction is taking place. Refractive index of this medium means medium 1 with respect to medium 2. That is written as N12 now. Okay, so this becomes N12. Okay, this is N12. Now, so we have a condition here. What is that condition? See, this normal and this normal are parallel to each other. They are drawn perpendicular to these interfaces. So this angle and this angle are equal. For the rectangular slab, this angle and this angle, they are equal. They are alternate angles, therefore they are equal. So R is equal to, this angle R is equal to I dash. And very importantly, this angle of emergence, will be equal to angle of incidence. This happens only in the case of rectangular slab, okay, not for the other cases. In case of a rectangular slab, this angle of incidence will be equal to the angle of emergence. Therefore, I is equal to E. By putting these two conditions in this equation, we will get sine I dash. Instead of I dash, I will write R divided by, instead of sine E, so instead of E we can write I. So this is sine I, and this will be equal to N12. Okay, N12. Now multiply equation, now call this as equation 2. Now multiply equation 1 and 2. LHS of the first equation is sin I by sin R into, LHS of the second equation is this, sin R by sin I. Sin R by sin I. This is equal to, Let us multiply the RHS. N21 into N12, correct? N21 into N12. Now sin I gets cancelled, sin R gets cancelled, and in the left hand side it remains 1. So 1 is equal to N21 into N12. So if you rearrange this, what happens is, I will be writing here, this is N21 is equal to 1 by N12. We can prove this. N21 is equal to 1 by N12 for this rectangular glass slab. Okay. Now in this situation, when the light is traveling from air to water, then to glass, medium 1, 2, 3, it is suffering 3 refractions. The refractive index of medium 3 with respect to medium 2, that can be written as N31. Refractive index of medium 3 with respect to medium 1 into N12. Refractive index of first medium with respect to second medium. We will not ask a proof for this, but you can remember this formula for your competitive exams. Okay. So I have forgot to say one thing here that you have to note it down. The first one is, when light travels rarer medium to denser medium, then I is greater than R. See, when the light is traveling from air to glass, okay, it is traveling from air to glass. We can compare air and glass and say that air is a rarer medium and glass is a denser medium, because light travels faster in air than glass. So in this case, the angle of incidence is more than the angle of refraction. Why? Because means, if this medium is absent, then light would go in this direction. But because of the presence of this glass, the light has bent towards the normal. Okay, it has gone towards the normal. So if it is going towards the normal means, if you compare the angle of incidence and the angle of refraction, this angle of refraction is less than the angle of incidence. So I is greater than R. In this case, N21 is greater than 1. Refractive index of second medium with respect to first medium is always more than 1. In the next case, if you consider the second one, well, in this condition, light travels from rarer medium to denser medium. I will be greater than R and N21 is greater than 1, and ray bends towards, okay, ray bends towards the normal. So you should understand a fact that when a light travels from rarer medium to denser medium, this ray has to be bent towards the normal. It has to bend towards the normal. In the second case, say for example in this case, okay, light has traveled from glass to air. Glass to air. Okay, light is traveling from glass to air. Here, this is the angle of incidence, and this E is nothing but a angle of emergence. I said this angle of emergence is nothing but a refraction only, angle of refraction only. So if you compare these two angles, this angle is lesser than this, correct? Means when light is suffered a refraction from denser medium to rarer medium, the light ray will bend away from the normal. So it goes away from the normal, so that the angle of emergence or angle of refraction is more than the angle of incidence. So in this case, angle of refraction is more than the angle of incidence, and hence N21. So in this case, you should consider this as a first medium and this as a second medium. Okay, this is a first medium and this is second medium. Then this N21 will be less than 1. So if you say that this is the first medium and the second medium, the light is traveling from first medium to second medium, where first medium is a denser, second medium is a rarer. So in this case, the value of N21 will be less than 1, and also the ray bends away from the normal, Okay, then a lateral shift. So what do you mean by a lateral shift? See, when a light enters into a rectangular glass slab, say that this is an incident light and we have drawn a normal here, and in the absence of this rectangular glass slab, light may travel in the same direction. Okay, it is traveling like this. Now in the presence of this medium, light suffers a refraction here. So at this point, the light suffers a refraction and it goes like this. Okay, it changes its path and it goes like this. Again at this point, if you draw a normal again, and here also refraction takes place and the light travels in this direction. Light travels in this direction. Now, if you just compare the incident light direction. So if this is the direction of the incident light, if this is the direction of the incident light, and this is the emergent ray, and this one is the emergent ray. This light, this path and this light is actually parallel to each other, correct? If you observe this diagram properly, the actual direction of the incident light is this. But because of the presence of the rectangular glass slab, it suffers refraction at this point and also at this point. If you compare the actual direction of incident light and this emergent ray, they are not deviated. They are going in the same direction only, but it is suffering some displacement, a lateral displacement, correct? A lateral displacement. So if you write this perpendicular here, if you draw a perpendicular here, and this perpendicular is this distance, the perpendicular distance is nothing but a lateral shift. Okay, so what is this lateral shift then? What is this lateral shift? A lateral shift is the perpendicular distance from the actual direction of incident light to the emergent ray. So what is this lateral shift? Lateral shift is the perpendicular distance from the actual direction of the incident light to the emergent ray. So I said that if the incident light is undergoing refraction at this point and this point like this, if this is the actual direction of the incident light, then the perpendicular distance between this actual direction of incident light to this emergent ray. So this is called as a lateral shift. So what is the phenomenon of lateral shift? When a light is traveling from air to this glass slab, what happens is at this point it suffers a refraction and also at this point. In the absence of this rectangular glass slab, light may travel in this direction. So there is a lateral shift in the direction of this light. This incident light is laterally shifted towards this direction because of this rectangular glass slab. Otherwise, it should have go in this direction. So this lateral displacement of a light ray is called as a lateral shift. So how do you measure the lateral shift? A lateral shift is nothing but a perpendicular distance from the actual direction of the incident light with the emergent ray. So if you say this is angle of incidence I and this is angle of refraction R, and this angle and this angle are opposite to each other and therefore they must be equal. So if this is angle of refraction and what about this angle, this becomes I minus R. Means to measure this distance, okay, to measure the lateral shift, we have an equation LS is equal to T into sine of I minus R divided by cos R. Okay, lateral shift means this distance is measured using a formula LS is equal to T into sine of I minus R divided by cos R. What is that T is? T is the thickness of this glass slab. So the thickness of the glass slab, let us write that. T is the thickness of the glass slab, and of course I is angle of incidence, and R is angle of refraction. Okay, so this is nothing but a lateral shift. So what are the things we have learnt in this class about the two laws of refraction? Okay, first law and second law. That too, a second law is very important from your examination point of view, which is called as a Snell's law of refraction. Snell's law of refraction says that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant, and that constant is called as refractive index of medium 2 with respect to medium 1. Then we learnt about the refractive index. A refractive index is a characteristic property of two pair of media, and it also depends on the wavelength. But the refractive index is independent on the angle of incidence. Then we learned two types of refractive indices, absolute refractive index and relative refractive index. And then we shown that N21 is equal to 1 by N12, means refractive index of second medium with respect to first medium is reciprocal of the refractive index of first medium with respect to the second medium. So we had shown that equation. Then we learnt about the limitation of Snell's law, that is where we cannot apply Snell's law. For the normal incidence, then I and R, angle of incidence and angle of refraction, becomes 0. In that case, we cannot apply Snell's law. That is the limitation of Snell's law. Then we learnt about the lateral shift, and we measure the lateral shift by a formula Ls is equal to T into sine of I minus R divided by cos R, where this T is the thickness of the glass slab, I is the angle of incidence, and R is the angle of refraction. Okay, so we will stop it here, and in the next session we will be learning about some more concepts of this chapter. Until then, thank you.